Physiography deals with the study of surface features and landforms of the earth. In today's class, we'll be learning about the physiographic features of India with respect to Himalayas. On the basis of tectonic history, stratigraphy and physiography, India may be divided into the following four physiographic divisions: the elevated peninsular region, the mighty Himalaya and their associated young fold mountains, the Indo-Gangetic Brahmaputra plains, the deserts, the coastal plains and islands. The Himalaya consists of four lithotectonic mountain ranges, namely the Trans-Himalaya or the Tethys Himalaya, the Greater Himalaya, the Lesser Himalaya and the Shivalik or the Outer Himalayas. The Indian Himalaya extends from the eastern boundary of Pakistan to the border of Myanmar for about 2,500 kilometers with a varying width of about 500 kilometers in the west and about 320 kilometers in the east. They lie to the north of Ganga Brahmaputra plains and are separated from the plains by the Himalayan front fault. They include parts of Jammu and Kashmir, Himachal Pradesh, Uttarakhand, Nepal, Sikkim, Bhutan and Arunachal Pradesh. Their offshoots run in a north-south direction along the India-Myanmar boundary through Nagaland, Manipur and Mizoram. The origin of Himalaya has been a point of contention among the geologists and geomorphologists. It is a complex mountain system having rocks from the Precambrian and Eocene periods. Mostly formed of sedimentary and metamorphic rocks, it has been subjected to intense folding and faulting. The main theories about the origin of Himalayas are the geosynclinal origin. The main supporters of this geosynclinal origin of the Himalaya are Argand, Kober and Suez. According to these geologists, the disintegration of Pangaea about 200 million years back led to the formation of a long Tethys Sea between the Laurentian Shield, the Angara land of the north and the Gondwana land of the south. This sea was occupying the region of Himalaya during the Mesozoic era, which is 180 million years ago. At the end of the Paleozoic and the beginning of the Mesozoic eras, the Tethys almost girdled the whole earth, running from Europe in the west to China in the east. Eroded material from the two land masses, which are the Eurasian Shield of Angara land and the Gondwana land, was deposited in the Tethys Sea and assumed considerable thickness due to the sinking nature of the seabed. During the Cretaceous period, the bed of the sea started rising, which led to the folding of three successive ranges of Himalaya. The first upheaval led to the formation of the Greater Himalaya during the Eocene period, about 65 million years back. Similarly, the second upheaval took place during the Miocene period, which is about 45 million years back, resulting in the formation of the Lesser Himalaya, and a third upheaval started in the Pliocene period, which is about 1.4 million years back, which resulted in the formation of the Shivaliks or the Outer Himalayas. The origin of Himalaya, according to this theory of plate tectonics, was put forward by W.J. Morgan of Princeton University in 1967. This theory is based on the concept of seafloor spreading advocated by H.H. Hess. According to this theory, about 70 or 65 million years ago, there was an extensive geosyncline called the Tethys in place of the Himalaya. About 65 to 30 million years ago, the Indian plate came very close to the Asian plate and started subsiding under the Asian plate. This caused lateral compression, due to which the sediments of the Tethys were squeezed and folded into three parallel ranges of the Himalaya. It has been estimated that this convergence has caused a crustal shortening of about 500 kilometers in the Himalayan region and is compensated by seafloor spreading along the oceanic ridge in the Indian Ocean region. Since the northward movement of the Indian plate is still continuing, the height of Himalayan peaks is increasing. The Indian plate is moving northward and the center of rotation is constantly changing. The continent-to-continent collision between the Indian and the Asiatic plates started around 65 million years ago and caused the Himalaya to rise from the Tethys geosyncline. Thus, the first major phase of uplift in the Himalaya occurred around 65 million years ago. This orogenic movement elevated the central axis of ancient crystalline and meta-sedimentary rocks which have been intruded by large masses of granite. It is believed that the first major phase of uplift initially produced the Ladakh and the Zaskar ranges of the Trans-Himalaya before the formation of the Great Himalaya. Hence, it is to be realized that except the Kashmir part of Himalaya, the Himalayan ranges have not developed from a geosyncline and are made up of elements formally connected to the marginal parts of the Indian Shield. During the main Himalayan orogeny, this continuous geosynclinal sedimentation led to the underthrusting of the Indian Shield against the Tibetan Massif, which buckled down the geosynclinal deposits, resulting in the outflow of a large amount of ultra-basic rocks known as the ophiolites. These ophiolites are seen as exotic blocks on the Ladakh and the Zaskar ranges of the Trans-Himalaya. The end effect of the buckling of the geosyncline was not only the crystalline thrust effect on Ladakh and Zaskar, leading to their rise as ranges, but also the creation of the sharp tectonic line of the Indus structure, along which large geosynclinal areas disappeared. The intermontane basins in the Indus structure zone of Ladakh continued to receive molasses sedimentation in this period. The second major uplift, which took place around 45 million years ago, caused the rapid uplift of the southern mountain front of the Lesser Himalaya, giving rise to the extremely rugged and youthful Pir Panjal, Dhauladar, Karol and Mahabharat ranges abruptly and steeply. The Greater Himalaya and the Lesser Himalaya are separated by the main central thrust. These spurs of the Lesser Himalaya again formed, in their turn, the intermontane basins of Kashmir, the Karol Basin, Doon Valley in Uttarakhand and the Kathmandu Valley of Nepal. The foredeep, which was formed further away, received the thick sequence of terrestrial sediments called shivalics from the middle Miocene to the middle Pleistocene periods, covering a span of about 1.4 million years. The Lesser Himalaya and the shivalics are separated from each other by the main boundary thrust. The 5,000 meter thick shivalics, dominated by boulder and conglomerate, reflect the progressive uplift of the Himalaya from which they have been derived as a result of the third major phase of uplift. The shivalics are separated from the northern plains of India by the Himalayan front fault. For a systematic study of the physiography and relief, the Himalaya may be divided into the following four divisions from north to south: the Trans-Himalayas, the Greater Himalayas, the Lesser Himalayas and the Shivaliks or the Outer Himalayas. Now let's look at them individually. The Trans-Himalaya. The Trans-Himalayas are about 40 kilometers wide. They contain the Tethys sediments. The rocks of the region contain fossils bearing marine sediments which are underlain by the tertiary granite. It is partly metamorphosized sediments and constitutes the core of the Himalayan axis. It has a great accumulation of debris in the valleys of defeated streams which could not maintain the southerly course across the rising barrier of Himalaya. Now the next feature, the Greater Himalaya. The Greater Himalaya rise abruptly like a wall north of the Lesser Himalaya. The MCT separates the Greater Himalaya from the Lesser Himalaya. The Greater Himalaya are about 25 kilometers wide with an average height of about 6,100 meters. Almost all the lofty peaks of the Himalayas, Mount Everest, Kanchenjunga, Nanga Parbat, Ghasher Brum, Mansalu, Dhaulagiri, Nanda Devi, etc. lie in the zone. The Greater Himalaya are composed of crystalline, igneous or metamorphic rocks which are granite, schist and gneiss. The basalt complex of Himalaya is Archean. At places, due to heavy thrust, older rocks are found overlying the newer rocks. The Greater Himalaya are almost a continuous range. The range has very few gaps, mainly provided by the antecedent rivers. The Greater Himalayas receives less rainfall as compared to the Lesser Himalaya and the Shivaliks. Now, the physical weathering is pronounced here. Erosion is, however, less effective over the greater Himalaya as compared to the lesser Himalaya. Being lofty, they have very little forest area. Now, the next feature, the lesser Himalaya. The width of the lesser Himalaya is about 80 kilometers with an average height of 1300 to 4600 meters. It consists generally of unfossiliferous sediments or metamorphosized crystalline. The main rocks are slate, limestone and quartzites. Along the southern margin of the lesser Himalaya lies the Orthochinitous belt of highly compressed upper Paleozoic to Eocene rocks, often containing volcanic material. Examples of the Orthochinitous belts are found between the Muir and the Panjal thrust in Kashmir, Giri thrust in the Shimla region, and the Karol and the MBT in Garhwal region. This region is subjected to extensive erosion due to heavy rainfall, deforestation and urbanization. Now let's look at the next feature, the Shivaliks or the outer Himalayas or sub-Himalaya. The Shivaliks extend from Jammu division of Jammu and Kashmir territory to Assam. In width, Shivaliks vary from 8 kilometers in the east to 45 kilometers in the west, with an average elevation of about 900 to 1500 meters above the sea level. It is not a continuous range, it is broader in the west and narrower down in the east. Between the Shivaliks and the lesser Himalayas are longitudinal valleys called dunes or dunes. Some of the important dunes are Dehradun, Potli, Kotri, Kathmandu, Chumbi, Karada. The Shivaliks are mainly composed of sandstones, sand rocks, clay, conglomerates and limestones, mostly belonging to the upper tertiary period. The Himalaya have also been divided by Sir S. Burrard into 4 divisions, namely the Western Himalaya, the Kumaon Himalaya, the Nepal Himalaya and the Assam Himalaya. Professor S.P. Chatterjee in 1973 divided the Himalaya into the following 6 transverse divisions from west to east. The first one, the Kashmir Himalaya. Sprawling over an area of about 350,000 square kilometers in the territory of Jammu and Kashmir, the range stretches about 700 kilometers in length and 500 kilometers in width. With an average height of 3,000 meters, it has the largest number of glaciers in India. The Ladakh region of Kashmir Himalaya is characterized by cold desert conditions. Ladakh is one of the loftiest inhabited regions of the world. The gorge of Jilgit is 5,200 meters in height above the sea level of water at its bed. Surrounded by the greater Himalaya and the lesser Himalaya is the Kashmir Valley. Having a height of 1,585 meters above the sea level, the total area of Kashmir Valley is about 4,920 square kilometers. It is a structural longitudinal dune. A special feature of the valley of Kashmir is the Kareva or the lacustrine deposits consisting of silt, sand and clay. These Karevas are mainly devoted to the cultivation of saffron and have orchids of apple, peach, almond, walnut and apricot. The Himalayan Kashmir by high snow-covered peaks, deep valleys, interlocked spurs and high mountain passes. Now the next longitudinal feature, the Himachal Himalaya. Stretching over Himachal Pradesh, it occupies an area of about 45,000 square kilometers. All the 3 ranges, the greater, the lesser and the outer Himalayas, are well represented in this region. The northern slopes of the Himachal Himalaya are clothed with thick forests and show plains and lakes, while the southern slopes are rugged and forest-clad. Rohtang, Baralachala, Shipkila are the important passes which join Himachal Pradesh with Tibet. The beautiful and highly productive valleys of the Kangra, Kullu, Manali, Lahul and Spiti lie in Himachal Pradesh. These valleys are well known for orchids and scenic beauty. Next feature of the longitudinal Himalayas, the Kumaon Himalaya. The Kumaon Himalaya lies between the Satluj and the Kali rivers, stretching to a length of 320 kilometers and occupying an area of about 38,000 square kilometers. Its highest peak is Nanda Devi. Among the other peaks, Kamet, Trisul, Badrinath, Kedarnath, Dhunagiri, Jaloni or Shivling, Gangotri and Bandar Poonch are important. Gangotri, Milam and Pindar are the main glaciers of Uttarakhand. The important hill stations include Mussoorie, Nainital, Ranikhet, Almora and Bageshwar. The Kumaon Himalaya are connected to Tibet by a number of passes, namely Thangala, Mulingla, Mana Pass, Niti Pass, Tunjunla, Lampiadhura and Mangsadhura and Lipu Lake. The next important longitudinal feature of the Himalayas, the Central Himalaya. This range stretches from river Kali to river Teesta for about 800 kilometers, occupying an area of about 1,16,800 square kilometers. The major part of it lies in Nepal, except the extreme eastern part called Sikkim Himalaya and in the Darjeeling district of West Bengal. All the three ranges of the Himalaya are represented here. The highest peaks of the world like Mount Everest, Kanchenjunga, Makalu, Dhaulagiri, Annapurna, Mansulu and Gosainath are situated in this part of the Himalaya. It is very few passes. The passes of Nathula and Jalepla connect Gangtok with Lhasa, Tibet, China. Kanchenjunga, situated on the border of Sikkim and Tibet. It is the third highest mountain peak in the world. It is 8,598 meters above the sea level and remains snow covered throughout the year. Some of the important rivers of India like Kosi and Teesta have their origin in this mountain. The next longitudinal feature is the Eastern Himalaya. These lie between the Teesta and the Brahmaputra rivers, covering a distance of about 720 kilometers with an area of 67,500 square kilometers. The Eastern Himalaya occupy the state of Arunachal Pradesh and Bhutan. In this part, the Himalaya rise very rapidly from the plains of Assam and the foothills of Shivaliks and are very narrow. The Eastern Himalaya includes the Aka Hills, Dafla Hills, Miri Hills, Abor Hills, Mishni Hills, Namcha Barwa. It has a number of mountain passes, among which Bomdila, Bomla, Tanga, Yongyab, Dipu, Pangsau, Sela, Dihang, Debang in the Arunachal Pradesh region, which are most important. In the Eastern Himalaya, due to heavy rainfall, fluvial erosion is quite pronounced. On the southern border of Arunachal Pradesh, the Himalaya take a southerly turn and the ranges are arranged in a north-south direction. Passing through the states of Arunachal Pradesh, the Tirap division, Nagaland, Manipur, Tripura and Mizoram, the Himalaya are locally known as Purvanchal. The main hills of the Eastern Himalaya are Patkaibum in Arunachal Pradesh, Naga Hills in Nagaland, Manipur Hills, Blue Mountains in Mizoram, Tripura Range and the Barel Range. On the border of Nagaland and Myanmar lies the Arakan Yoma. These hills are heavily forested. Northern Myanmar is connected through Dipu, Hupkan, Chaukan, Pangsau and Likhapani region of Arunachal Pradesh. Southwards, a pass joins Imphal with Mandalay. The Purvanchal is joined by the Meghalaya plateau in the west. The extension of the Myanmar mountain chain continues southward up to the Andaman and Nicobar Islands and even up to the archipelago of Indonesia. The general east-west trend of the Himalaya terminates suddenly at its western and eastern extremities, and its ranges are sharply bent southward in deep knee bent flexures which are called syntaxical bends. The western syntaxical bend is near Nanga Parbat, where the Indus cut a deep gorge. The geological formations here take a sharp hairpin bends as if they were bent round pivotal points obstructing them. There is a similar hairpin bend in Arunachal Pradesh, where the mountains take a sharp bend from the eastern to the southern direction after crossing the Brahmaputra river. A glacier is a body of dense ice that drifts under its own weight. A glacier is formed by accumulation of snow exceeding its ablation point over many years. It is the largest reservoir of fresh water on the earth, about 75%. The lower limit of the perpetual snow is known as the snow line. The snow line in the Himalaya has different heights in different parts depending on the latitude, altitude, amount of precipitation, moisture, slope and local topography. The snowline in the eastern Himalayas and Kumon Himalayas is about 3,500 kilometers in altitude and is 2,500 kilometers in western Himalayas. The difference in the snowline is attributed to increase in the latitude from 28 degree north in Kanchenjunga to 36 degree north in Karakoram. In the Himalaya, glaciers or the snowfields cover about 40,000 square kilometers of area between Karakoram and Arunachal Pradesh. There are about 15,000 glaciers in Himalaya lying between the two syntaxical bends in the east and the west. In the Arunachal Himalaya, the snow line is about 4,400 meters, whereas in Kashmir Himalaya it varies between 5,200 to 5,800 meters. In the Kumaon Himalaya, the snow line is about 5,100 meters and about 5,500 meters in Karakoram. On the Tibetan side, the altitude of snow line is about 900 meters higher owing to the great desiccation of the region and scarcity of moisture. Thus, there is a direct relationship between the presence of moisture and the altitude of the snow line. In general, more the moisture in the atmosphere, the lower the altitude of the snow line and vice versa. The main glaciers in the northern mountains are found in the Greater Himalaya and the Trans-Himalayan mountains, namely the Karakoram, Ladakh and Zaskar. The lesser Himalayas have small glaciers, though traces of large glaciers found in Pir Panjal and Dhauladhar range. The glaciers of Karakoram are the remnants of the Pleistocene age. The diurnal rate of the movement of these glaciers is between 8 to 15 centimeters at the side and 20 to 30 centimeters in the middle. The glaciers of the Pir Panjal are less numerous and smaller in size as compared to those of the Karakoram and Greater Himalayan ranges. The glaciers of Nanga Parbat Massif are small in size and are moving fast due to a steep slope. The glaciers are not only the source of Himalayan rivers but also maintain a regular supply of water in these rivers during off-monsoon period. The Himalayan glaciers are, however, receding. According to ISRO satellite study, 75% of Himalayan glaciers are melting, 8% advancing and 17% showing no change. Commissioned by the Environment Ministry, the study is different from the IPCC report claiming without sufficient evidence that the glaciers would vanish off by 2035. The average retreat of the Gangotri glacier is about 12 meters per year. It has retreated more than 1500 meters during the last 70 years. The land of India displays great physical variation. The Himalayas are the most recent landforms. The Himalayas, geologically young and structurally fold mountains, stretch over the northern borders of India. These mountain ranges run in a west-east direction from Indus to the Brahmaputra. The Himalayas represent the loftiest and one of the most rugged mountain barriers of the world. They form an arc which covers a distance of about 2,400 kilometers. The width varies from 400 kilometers in Kashmir to 150 kilometers in Arunachal Pradesh. The altitudinal variations are greater in the eastern half than those in the western half. The Himalaya consists of 3 parallel ranges in its longitudinal extent. A number of valleys lie between these regions.